Okay, hi guys. I did my project on LCD projectors, which is something that schools and businesses use a lot to present different ideas instead of, the boring old presentation with a board and an essay. So they're really cool, and personally, our junior class uses them for rallies, and so that's a reason that I wanted to do them. Okay, so LCD projectors are actually short for liquid crystal display, and they broadcast images on a flat surface. And what happens inside is that high intensity beams of white light travel through thousands of shifting pixels, and they basically travel through three displays, turn into colors, which is the only three colors we can see: red, blue, and green. And they regroup in a prism with each image, and they broadcast through the projector lens. Now, I'm going to go deeper into that and explain what all of that means throughout the presentation, but let's just keep going right now. So, when you're using your projector, your LCD chip gets an electrical signal and wants to create an image. And so, as the light travels through the projector, it is split into three different, I guess you could say, streams. And the streams each turn into a color. One is red, one is blue, and one is green. And at the very end, all those colors come back together. Each image, which there's a red one, a blue image, and a green image of the same picture, they all go over each other and they form a multicolored image. And so that's what you see when the projector puts the image on the wall. Okay, so this is the light source that the white light comes from, and these are the two dichroic mirrors, which are mirrors that are coated in a special film that reflects only a specific wavelength of light, and so they reflect the red and the green, and then you have one regular mirror that reflects the blue, and the light is beamed through and splits into three different hues and ends up going into three, images into the LCD screen, and they all go together and they project onto the wall. Alright, so although you can't see it in this picture, the light beams have to travel through thousands of tiny colorless pixels. And what the pixels do is that they either block light or allow it through when triggered by an electric current. And so, some explanations for everything, so you guys don't get too confused, is like the white light beams hit three mirrors, which I explained before, one regular and two dichroic. The dichroic is coated with a thin film that reflects only specific wavelength, so it's safe to say that each one has a different wavelength, and that's why you get certain colors. And it divides the reflected light into RGB, which is red, green, and blue light. The LCD panels have a HTPS chip inside, and an HTPS chip is a high temperature polysilicon, and it basically creates higher resolution and contrast, makes the picture really sharp and clear, and that's really what LCD projectors are really known for, is having clear, great images that you can see and that don't get ruined. And so each beam creates an image in the color RGB, and the images are placed on top of the other to create one multicolored image. Now, at the end, before the image is broadcasted through the lens, the dichroic prism has to be formed, and all the light comes back together and is formed into the prism, And this is also what happens with the HTPS chip. And so here's a couple of pictures, shows the light being transmitted through, because green is the only light that's transmitted. Red and blue are reflected. And this is like a summary of RGB. This is the light you see, and all colors are not just made out of, nowhere. They're all made out of red, green, and blue. And when you see, different colors, you're just assuming, no, this is purple, no, this is yellow. No, it's really, RGB. So just think of that acronym every time you see colors, RGB. But this is an HTPS chip, and that is inside projectors, and that's what it is. And then, like we said before, the light beam splits into three hues, red, green, and blue, and travels through the pixels. And the pixels block or allow light when triggered by an electric current. And one thing is that they're constantly moving, and they're moving at a slow pace, probably about 4 pixels every 5 minutes. To make sure that the image that you're leaving on your screen is not burned into the screen. And on the next slide, I have a picture of a burned in image on a screen. But basically, if you leave an image on your screen too long and your pixels aren't moving, then the image can kind of leave a ghost of what it looked like, kind of like a whitish image behind it. And you might have seen this on your TV if you paused it, or just, it was stuck real quick. And so here you kind of see like this burned in image. I'm not exactly sure what it is, but you can see that it's kind of left behind right there. And you don't really want to see that, because if you're looking at something that's a different color, it might get in the way of your sight. And here's another picture of the inside of a projector. You can see that the light goes through the converters and goes and hits the dichroic mirrors and the reflection mirrors, and all come together and form one. And so what the polarizing converter does is that the HTPS chip only distributes longitudinal waves. And so this polarizing converter helps turn all the shear waves into longitudinal waves, so that as many of them can get through the HTPS chip as possible. And this is to help increase brightness, which is another thing that LCD projectors are known for, along with being just great clear images, great zoom, really just great light, and not they don't wear out very easily. And then here's another picture of what some different projectors, some are different and some are more similar, but I'm kind of giving you an overview of how most of them work. And so you can see that this is projecting lens projected the image. You can see that they have a color filter, so you can see the red, the green, and the blue. And then that is it. Projectors are such a cool item. They really help, revolutionize the time. And they just they're just a great help. And I think LCD projectors are probably one of the best things on the market. Their contrast, their zoom, you get a clear pic every time, anytime. They don't experience what's called a rainbow effect, which is you see color flashes, which happens in other types of projectors. They're usually very cheap, and they have a low energy consumption, which is really good for the people who really care about those certain topics. So thank you for listening, and I hope you really liked it. It was my first video. So don't judge me too harshly, but I hope you learned a lot about how LCD projectors work. And if you need more information, I used a great website called 3lcd.com, and it will really help you out. Thank you so much.